Hello everyone, I am Aharnish Bagchi, and today I will be talking about integrating large language models with web applications. Now, large language models are a pretty big hype right now in the current market, and web applications have always been a dominant factor in the CS field. So, I believe combining these two different topics would be a great discussion to have right now. Moving on. Um, What is LLM, first of all? We have seen this terminology everywhere in the recent times. Everyone is talking about AI, LLM. Even if you see like different discussions going on in big companies like NVIDIA's hosting events, everyone is speaking about AI. But what is like LLM? LLM stands for a large language model. It is a basically sophisticated machine learning algorithm which is trained on a lot of data, like petabytes of data, or even more than that actually. What is this data about? This data can contain many things, like since its name says large, so it's basically trained on a lot of various factors. Suppose coding, general applications, reasoning, etc. Now, the data that you feed to the training of the LLM cannot be like directly given as raw data. It needs filtering. And the process of filtering is a pretty tedious one and is the most time consuming too. Now, what are some normal examples of LLMs? Now, we all have used ChatGPT, and then there is Llama, then we have Gemini, and there are many other models, Mistral, open source models, GPT OSS, and all these. Now, this is one side of the discussion. Another side being what is a web application? Web application is basically a client server software that you can access using a browser. You don't need to download it like an exe file or a direct APK file. You just need a browser and an internet connection. You can just connect to any website that you wish, and you can visit the contents and perform actions, whatever you want to do. Now, to build a web application, it generally has two different aspects, one being the front end and the other being the back end. Front end is basically whatever you visually see in the website, like the text boxes, the content, the buttons, the color schema, and all these, the font size, the font style, and all these. Now, generally, the stack that is used for front end includes React and CSS, Bootstrap, and all these. For the back end is basically suppose you click a button in the website, what action will it perform? That logic is basically performed in the back end of the website. Now, for the backend, you have these APIs, then you have these databases, and all these extra etc. things. For this, also mostly Node.js is used, and then you have MongoDB. You can use Python also if you wish to. There are various tags based on your convenience. Moving on. When did this whole um, AI thing start from? What was this? What was the big bang of the AI basically? Now, AI has been in the market for quite a long time. AI has been used extensively by YouTube algorithms. Like the basic YouTube algorithm is basically an AI, if you see in a broader sense. Similarly, for Twitter, Instagram, and all these other platforms, also. This is just one aspect. Now, before 2017, we had RNN and LSTMs networks. Uh, LSTM is basically long short-term memories. It's also a kind of RNN networks. But then we also had CNN networks, convolutional neural networks, which were at the peak at that time. Now, CNN networks required a lot of training, and the results that it bore were not up to the level. Like the ratio was not that good. Now in 2017, Google released a paper which was like attention is all you need. Now this paper basically introduced the transformer architecture. Transformer architecture is basically the underlying uh, architecture behind all the LLM models that you are currently seeing in the market. Now, it emphasized on a particular concept of attention. Basically, we will discuss about this further in the slides, but just to give you a broad sense idea, attention in the sense like which context, like which elements of the conversation needs a higher attention, which needs to be more focused, more prioritized. That was what helped um, transformer architecture gain an edge over the existing systems. Now, as I said earlier, you have seen these kind of LLM models in like Jama, GPT, Llama, and all these. Moving on. Now, we won't be covering all the attention is all you need research paper thing. It's like pretty complex. I don't know that much. But then we will see a simple base understanding of how things work. The most important part is the transformer over here. Now, transformer consists of various attention blocks, various layers. Okay. Now, each attention block will basically have a long list of numbers. Now, if you see over here, mm, let me get a pointer. If you see in this image over here, you can see like we have the sentence drawn by the river bank. Now, what happens is this is basically the context that you have given. This is your query, okay? Now, every word is converted into a long list of numbers. As you can see over here, it's not basically numbers, it's more like matrix, if you see. Now, every word is converted into a matrix. It's converted into a number representation. Why do we do this? That's how this architecture works. Don't question everything. Um, so, so you convert all this into numbers, and with each iteration, like this process, converting into numbers and then understanding, is repeated for n number of times. For every sentence, it's repeated like various number of times, and with every repetition, the model is better able to understand the statement that you have just said. So that is how it develops the understanding. Now, there is another two terminologies that are involved in this, which is called like weights and bias. But we won't get too much into that. Now, after this whole training procedure, what do we get as a final result? The final result is our legendary GPT, which we use for writing assignments. Now, as you can see, one small example is now suppose mm, I mentioned something like bank. Now, the word bank can have two meanings, one being the river bank and the other being the ATM bank. Now, how will the model know which bank am I talking about? This is where self attention comes into place. It won't just focus on that bank word, it will see the nearby words that were around that statement. So, like if I say something like, I am sitting by the river bank, so that particular emphasizes that I am talking about the river bank and not the ATM bank. This understanding, this level of understanding is what is developed by this transformer architecture. Now, there are some technical terms like query key value. We won't get too much into it, but then just for a overview, query is basically a vector. Key value are basically two matrices, and first you just multiply, do a dot product of query and the key, and then the resulting is again done permutations with the value, and then you get a new matrix, which is the new understanding of the model regarding the words. Moving on. Why should we even bother to integrate LLMs into our regular applications or our day-to-day lives? One obvious reason being is it supports natural language. What more do you want? You don't need to learn any programming language to talk to LLMs. You don't need to learn Python, C++, assembly, Dart, or anything like that. You can just talk to it naturally. Talk to it in English or Urdu or whatever language you are comfortable with, and it will give you pretty good accurate responses. Moreover, since LLMs are trained on a very large amount of data, you can basically use their experience, you can use their analysis for automating various tasks. Uh, Moreover, if you give it enough context, enough information about yourself or about the data that you want the model to answer about, it can do that as well. So basically called as hyper personalization. We will see example of this hyper personalization ahead in our PPT. Moving on, another application can be now if you're applying, there is a high probability that you will be using an API for that. Now, what is an API? API stands for Application Program Interface. Now, what does API do? API basically connects your front end, the query, the user, and the LLM model, which is in the server in the cloud. How does it do that? We won't get into too much architectural understanding, but for just a basic understanding, first of all, you will have a initiating the call, like basically whatever message I'm writing. Like if I write, "How are you?" How are you message is packed as a API request along with metadata. Metadata is basically extra information that is given alongside the user query. Why is it given? Well, it depends. Like you might have browser cookies, you might have date and time, your location. Like this particular message was given from India or something. Just an example. All these information is involved in the metadata. Many other things are involved too. One more thing, important thing which is involved is authentication. Authentication is basically you are the person, you are the exact person who is contacting, who is having a conversation with the AI model. This is really important because we'll be seeing how authentication exactly works when I'll be showing you the code implementation. Moving on, how does that API thing work then? Now, once you have sent the request and the API has gone to the server, now in the server, it will receive your user query, and it's not like server is a very big room, okay? And it's not like there is only one AI model over there. Suppose you are using GPT, it doesn't mean that when you're writing a query that in the server there is only one GPT 5.1 model. It doesn't work like that. There are a lot of GPUs in the server room. Now, each GPU cannot hold the whole AI model, so we call it as a GPU cluster. What is a GPU cluster? It's basically a group of GPUs together. Group of GPUs together work as one whole GPU and that contains the language model. Suppose, for example, GPT 5.1. Now, there is not just one GPT 5.1, there are like probably thousands of GPT 5.1 working together to handle the huge sheer amount of requests that it receives. Now, one terminology which is pretty common in all this thing is tokenization. What is tokenization? Now, whatever text that you're going to pass, that text is basically converted into small parts, which we call it as tokens. Now, these tokens are then used in various different manners. We will be seeing about these in the future slides. And yeah, so you get the tokens, and then you have this context initialization. Basically, KV cache is one technology that is used for optimized retrieval of memory of your chats. I won't go into that too much. Let's move on right now. So, how you can basically integrate the LLM. Suppose you're having a website. Suppose you have a website for like bakery or something. Now, in that website you want to integrate with AI. What will the AI do? It will basically have content of your bakery things and it can respond to users about your bakery questions. How would you achieve that? You will have first of all the front end, the website, the obvious website which the user will interact to. In the second part you will have the orchestration layer. Basically you will have the database, like how many cakes do you have, and the information, the phone numbers or the members who are part of your store. You will also have the AI model backend, the server calling and all that, or everything comes under the backend. Then you will have the intelligence layer, LLM API. So you will connect your AI model with the front end through the server using an API. There are various AI API providers. You have OpenAI, there is Gemini, there is also Grok, which is a third party one. It involves various models. You have Open Router. There are various ways. And then when you pass that, the processing will be done in the backend, and then finally you will get the response in the number four. Moving on. Now, obviously, LLMs are pretty cool. They are awesome. They have various advantages, but then there are also some limitations. One of the biggest limitation is they hallucinate a lot. What do I mean by hallucination? Hallucination is basically when you ask it a question, it doesn't give you a proper answer. It gives you a very vague answer. What are the possible scenarios when it can give you a vague answer? Suppose you ask it to predict something, like you say, what will the world look like in 2037? Something like that. The event hasn't occurred yet. What it will do is it will just run a series of probabilities. what it thinks or what it thinks might happen is what it's gonna say. In most cases, current AI models are pretty efficient and they can give you a good answer, like good enough answer. But if you see the earlier models like GPT-2, like 3.5 Turbo, they were not good at predicting the future and they will hallucinate. They will just say gibberish. They will just say some random words which don't make sense. That is called as hallucination. Another reason of hallucination is context window, which we'll see ahead. And yeah, as I said, hallucinations. And another challenge is being like data privacy. Now, models which are publicly available might not have a very good data privacy. Now, one thing which is like pretty common right now is SQL. You might have heard about SQL injection, which is basically injecting a small piece of code into the SQL database, which then gives you the complete access of SQL database. Similar kind of thing only, but this also works with LLMs. It's called as like prompt injecting. So you basically give kind of a little prompt into the LLM, which causes it to malfunction, and then you can make it behave the way you want. So it's like a privacy concern. It's definitely a privacy concern. And third being lack of domain knowledge. Suppose you want the model to know about your company's specific internal documents. Now, obviously, if you go to GPT and ask it, what was my boss talking about? What document did it want yesterday? Obviously, it won't be able to answer it because it doesn't know about all those documents. Now, that is also one limitation. Like, it won't have a complete domain knowledge. You need to give it. And one way to achieve that is RAG. We will talk about that ahead. Now, what is RAG? Before getting into RAG, I would like to show you a small code implementation about um, about this whole thing. Now, this is basically a small code implementation, 31 line code implementation of how basically you can chat with a cloud LLM model. Now, this whole schema, this whole code is basically Python, more particularly LangChain. I have used LangChain library mm, to give you a better sense of things. I will explain you. Like as you can see over here, the first four lines are basically imports. If you are a little familiar with Python, you might know we gotta import some things. So LangChain core is one library. LangChain grok is also one library, which I am basically using to import right now. Importing chat prompt template and string output passes. And here is one very important thing, which is like grok API key. Now API keys are very important when you talk about LLM models. Why is that? As we talked earlier about authentication, right? API keys are one ways you are able to authenticate yourself. So API key will be a long series of numbers which will be uniquely given to you. Now, whenever you need to talk to a LLM, you need to give your API key as reference, which basically tells the server that it's particularly you who is trying to access the AI model. Now, I can't show you the API key directly because obvious reasons, but I can do show you how does this look because I have taken a reference from the OS module over here. So if you see, you need to make a small file named as .env, which is over here. So you need to make a .env folder, and within that you can just write your grok API key, whatever is the variable name, and within the double quotes you can just paste your API key, which will be a long series of numbers. Once you do that and then you just use this os.getEnv, you can basically fetch all the environment variables from that file to this particular code. This part is done. Now, this is the model, the main part, the brain of this whole code. Now, in this model function, chatgrok is basically a function, okay? Now, within this function, I have two parameters. One is like the model name. What will be the model name that I'm passing? And the second being the API key, which I told you, which is very important, by the way. Now, in the model, I'm currently using GPT OSS, by the way. Pretty good model. And the API key is already been fetched from the environment variables. Moving on, there is this prompt. Prompt is basically the set of instructions that you give it to the language model. Over here, I have just given it a normal statement like your name is clauses and you need to answer questions with the best of your knowledge and answer the query of the user. user input over here. Here is a small while loop, which basically, whenever I ask a question, I get a response, and then again it goes to a loop for waiting for my next question. I just wrote this thing to just give it a good sense of like a chat conversation kind of feel. Here is one another important line, which is like chain. This is one of the advantages of LangChain, which you get by using this library is like now here you can see I have used this pipe operator. This is basically like a pipe operator. Now what happens is prompt, right? This is the prompt. Now first I the prompt is evaluated. Whatever I ask, the question is inserted over here, and this whole thing is then passed to the model. The output of the prompt is then passed to the model. The output of the model is then passed to string output parser. That is how this pipe operator works. We call it as chaining in the language of LangChain. Now, once you pass it to the model basically understands all this chat template, whatever I wrote over here, and then gives me an output from the cloud. Once I receive that, I pass it to another function, string output parser. Basically, it just filters out the main content and gives it to me. That's it. Then I'm just printing it over here. Let's just try it once. I'll just write a simple statement like hi. And here it is. I got a response. Hi there, I'm Clausus. How may I help you? I will give it a task. Write a 500-word essay on LLMs. And here we go. We have a 500-word essay on LLMs. As you can see, it's pretty big though. Large language model, rise of contextual AI, and all this content. Pretty good. We'll just exit right now. So yeah, that was the way. Now, this was how it works. Now let's come back to RAG. What is RAG? RAG stands for Retrieval-Augmented Generation. This was another technology which came up around 2021, 2022, launched by Facebook in one of their research papers. Now, this thing is basically used when you want a LLM model to exclusively answer your queries from your own specific knowledge base, your own specific data. What do I mean? Basically, when you give a basically when you ask a question, suppose related to your company data, you have to give your company files and data beforehand to the AI model. What happens is whenever you're asking a question, it will refer to that database, it will get the answer from that database and then respond to you. That is highly beneficial because your data stays locally with you. It's not going out of the system. Moreover, it's answering your own database. That's also a plus point. So you are solving the problem of hallucination. You're also solving the problem of domain knowledge. What are the core components of RAG architecture? Basically, what are the core terminologies that you will hear in this whole RAG conversation? One is embeddings. What are embeddings? Embeddings are basically numerical representation of text. What do I mean by that? Suppose you have a word, let's say desert. Now, there are again two different meanings of desert. One desert is basically like the Thar desert kind of thing, the like desert, and another desert is ice cream desert. So there are two different meanings. So what happens is this word desert is converted into a long list of numbers, which are basically like matrices. But then since I gave it a word desert, right? Now, since the word is the same, but the meaning is different. One desert is the Thar desert, another desert is the ice cream desert. The value, the numerical representations, the numbers that they will be denoting will also be different. Why are they different? Because the context is different. So that is how embeddings work. We'll see how these work further ahead. Now, what are vector databases? Vector database are basically like how you know, right? RDBMS and you have other MongoDB database and all. This is also another database which stores information in the form of vectors. What What are vectors? Again, collection of embeddings. So you're basically storing embeddings inside the database. Why is this efficient? Storing numbers is much more easier than storing words and a lot of words, basically. Now, we also have LLM reasoning, the big brain of our whole system. The LLM, which basically fetches the data from the vector database and then processes it. We'll see that further. Let's see this step by step. What is even happening over here? Let me show you with an example over here. Now, this diagram is pretty good. Here you can see you basically give your documents over here. Okay, you're giving your documents, and your documents are basically converted into chunks. What do I mean by chunks? Suppose you have a document, say, of a 10,000 word essay. Well, 10,000 word is not an essay particularly, but like you have a document of 10,000 words. Now, if you pass that whole 10,000 word thing at once to the LLM model, it might not be able to process it. It will go out of its context window. What is a context window? Context window is basically the level of capacity that the LLM model can process at a given time, at a given instance. Like at any given point, how much data, how much information can it process? That is context window. Different models have different context window. Gemma 2 has like 8,000 tokens context window. Now, some models have 32,000 tokens context window like that. So what are we doing over here in RAG is we take that document and divide it into chunks. Each chunk will have some certain number of tokens in that. So if we have a 10,000 word document, we divide it into some chunks of each chunk having around 500 words. And then we pass this 500 word chunk all together and convert it into embeddings. Basically, we are making number representations of those words. Then those numbers are being stored in the vector store over here, this part over here. Now, after storing it over here, now this one part is done. Second part being the user, we are going to ask a question to the model. We ask a question, suppose what are the kinds of desserts you have in your bakery shop, maybe. So now what will happen is I ask this one whole question. This whole question is passed to the embedding model. Now, again, the embedding model will convert my whole word English sentence into numbers. Converting into the numbers, again, it goes into the vector database. Now, there is a term called as similarity search, which is done within the vector database. It's basically comparing the two numbers, and the numbers that it finds closest to our question are basically the answers. Now, when you get those answers, basically after doing the similarity search, you will get those responses which are similar in the number variations. Those relevant context documents are then passed to the AI model over here. Now, what does AI model basically receive? It is receiving two things. It is receiving the user query question. It is also receiving the retrieved documents which are similar to the user's question. Passing these two things to the LLM. LLM will take it. It will read all those things. It will frame a proper answer, and then it will give you a cute little response. That is how this whole RAG thing works. This is the basic architecture. You can modify it for many more use cases and many more technologies. That is what the whole thing I have written over here. Again, RAG can also be implemented in your websites. Basically, you will have a front end UI, you will have a chatbot, then you will ask a query question. It will go to your backend server using through the API or Flask or Fast API, whatever you are convenient using it. Then again, it goes to the RAG engine where it will again do the processing of this documentation vector stores, and then it will pass it to the LLM, passing it to the LLM, and then again you will get the final response. Now, what are the use cases of this RAG models? You can use it for like banking and finance. Suppose there is a company, let's say there's a bank, say SBI. SBI has various documents regarding their finance and their insurance policies. They can create a chatbot that is highly specialized regarding insurance policies. How will they achieve that? They can just give all the documents into the vector store and then uh, uh, So you can have documents regarding your finance and related documents and pass it to the AI model. You can also use it in the education format, basically pass all your educational materials, your specific curriculums, your institution documents, and ask questions relevant to that. Similarly, for IT support also, we have various customer support platforms. You can also integrate AI with that. How is because like you can give it all your information regarding your company. So when user ask a customer query question regarding your company, you can basically forward it to your AI, which has a pretty good knowledge about all those things because thanks to RAG, and it can provide you with very accurate pinpoint answers. Moving on, yeah, we have discussed it. You can also use it for advanced conversational agents. ChatGPT is a good example of advanced conversational agents. You can also use it for co-pilots and assistants. Basically, uh, you can use it to build agents which can do particular tasks, make code or make PPTs for you or something like that. Now, what is the current AI tech stack in the market? If you see, now for the front end, you can see React is pretty popular. Tailwind CSS is highly used. It's all these frameworks are pretty good for creating your front end logic. For the back end, you can use LangChain for orchestration of your AI model, managing it. You can use Fast API for connecting your services. You can use Node.js, Express.js at your convenience. What are the different model providers? There are various model providers. OpenAI is pretty popular among them, but Gemini, Anthropic, all these are pretty good too. If you are searching for like local models or like open inferencing, you can visit Hugging Face or you can use Grok. Olama is also good. Olama mostly focuses on your local inference. Basically, you run the local model on your own device and then use it with your applications. So there is no cloud server over here. It's just your own machine acting like a server. Pretty good, by the way. Then you can also you for the memory and data thing you can use Pinecone Vector DB, Postgres, and Redis for as per your convenience. Now, if we conclude this whole thing, how does the future of intelligent app looks like? For now, there are still various limitations in the whole AI field, and there are still a lot of scope of improvement. But then, to combat those limitations, we are also finding new ways. Like we solved the problem of hallucination up to an extent using RAG. We are solving the problem of not LLM models not being able to take actions by introducing the idea of AI agents again using LangGraph or using n8n or anything of your convenience. So there is a lot of scope of improvement, and we are rapidly improving in this big field of AI right now. And it's always very exciting to be witnessing a new, improved technology in a very short time. So thank you very much. This is all that I had to say. Hope you like it. We'll see you next time. Bye bye.